Took an idea from Hayden's little miniature golf game-ish type thing. I just have three, I guess you can call them greens, three holes, and you play through you play through them one at a time. So when you clear one, once you get the ball in the hole here, it moves you to the next scene, which is actually one, and then you move through this one. So I put a little messing around, I guess, make it miniature golfish as a prototype. So this one has a little ramp, and here this is the tee. So you shoot from up there. How it works, don't need the scene. Right now, how it works, you spawn, you get an orientation automatically always to the hole, and you get a sort of a button press bar. Because of the delay of the stream, it took a. This is the method I came up with. So you send in your command. In this case, I'll be pressing the middle mouse button, and that's the first step. So now I clearly see I'm off my mark. Now I need to introduce the correcting angle. So for me here, I'm gonna do it from here as you normally would if when you were designing. So you can go minus the angle of difference or plus the angle of difference. So at 0, you'll be shooting straight ahead, and at minus, you'd be to your left and to your right. What? I didn't even realize it was happening. So now, let's say I would be sending in a -4 of an angle difference. I mean, everything could be adjusted, of course, from 100% to 0 or whatever. Yeah, yeah, definitely. We haven't added any commands. We're starting brand new. We're bringing it in, and we see what we need to do to make this work on Twitch. And that's another part of the testing phase. To run in an outside project, outside environment. So once we get the adjusting, in this case, my power can adjust it here, and I press the the left mouse button, and I'll shoot. And here we go again. And then you wait when the ball stops. Then it gives you your aimer again. Then you take your shot. You adjust your angle, so that will give the player an actual time. So this is where the skill comes in. Is this 7 degrees off the mark, or is it 40 degrees off the mark? So I'd go with 40 degrees off the mark now. Well, I mean 7 degrees. And let's fire. Awesome. So then it takes you to the next level, automatically orients you towards the hill and give you a range of fire. Now the range of fire can be adjusted on the aim controllers. I'm using a very small min-max angle now. Of course, we can make it a very large min-max angle to where it'll be much more difficult for you to adjust your aim. And I don't think I have. I could just try it. I don't think I have adjustments for angles that wide now. So here you see we're still off by a bunch, which will make the game a bit more interesting. Then you know you have a second shot coming. So now let's send in some commands from Twitch to make this thing work. So I'm thinking, do I create a new scene or? Yeah, because I don't want to mess up what I have already. Well, I kind of sort of do. I'm going to duplicate this. So there's probably going to be lots of problems with script names and stuff, so that's not going to work. I'm not going to be changing any of the scripts. So Well, we might be adding scripts or changing scripts. Yeah. So definitely, we're gonna be changing stuff. So before I get started, I'm gonna make a copy because I didn't push anything to the repository for this project. So if I mess things up, be totally screwed. All right, cool. Thanks. You like it, man. So we'll screw around with this and see if it all works. Well, I'm gonna have to close Unity to get a full copy. Unity locks a few files. All right, so let's start that up again. And let's do some UniTwitch integration. Actually figuring out how to allow people to fire to tee off or even hit the ball or like how do you do that? I mean, they can't just press a button and it'd be fired off in any random direction. This I got it to work. All right, let's import our package. I think I can go back. Gosh, please no errors. This is where it starts. Import everything. I gotta remember to take my credentials off of that thing. But you'll never be able to actually get to the credentials. It's hidden in Unity, but that particular string is being passed through a Unity CS file. So you can just set a breakpoint there and inspect the variable, and you have the. Let's see, you gave up, Curtis. Yeah, you gave up on playing police. Okay, here in the main. Excuse me. Excuse me. Here in the main scene, let's see what prefabs we can pull. So for Twitch, we need the Twitch IRC chatter, and you can copy and paste. So I'm gonna head to this scene here where I have it, and I'm gonna just copy it out. I think this is all we're gonna need for now. Let's go back into the other scene. Amenities, scenes, main. Don't save, and paste it right into the scene. Copy and paste from scene to scene. Okay, so now we have our Twitch chatter. We have to get our scripts open up so we can get to the commands for moving and aiming the ball. And it's spin all up. I think my computer's doing pretty good tonight. Nice. All right, so here we are in mini T's. What do we have? See, we have all the code here. And these are all code on this side that I left here on purpose. I want these to be accessible to everyone out of the actual DLL so they can see how I did these particular things. Because in reality, well, that's how I did it. I used the API to do this. So I left the code so that everyone can see how it's done. So you can in turn use the same API to produce Twitch chat connection with whatever other application you're using. It doesn't have to be Unity. Because I don't know if you can import DLLs that's made in C Sharp into an Unreal Engine, for instance, and you have all the same capabilities. You just have to write your own wrappers. Because I only did Twitch wrapper here for Unity, so it works in the same manner. So we don't want to do anything in Twitch IRC, at least right now. This is what we're here checking to see if we do need to modify things. So in our aim controller, coffee's here getting cold again. So in our aim controller, we have a few things exposed. The aim controller is what I had the most problems with, working with the quaternions and the angles and all those things. Math is my favorite because it never lies. It's guaranteed to be true. But it's also the hardest thing to wrap your head around a lot of the times, and makes coding difficult if you don't have a decent handle on mathematics or maths, like they say in other parts of the world. So that's kind of sort of what's going on here. Most of it I understand. The actual part of how matrices and quaternions are multiplied and how they work, I do not understand. How the vectors are added and scaled, I understand that. And how vectors are rotated and moved to different positions, I understand that. So, for instance, vectors always start at the origin, you can assume, at 0, 0, 0. And the first thing you'd want to do is rotate the vector and then move the vector. Because if you move the vector first and then you rotate it, you won't see the rotation effect because it was done after. And all rotation does is spin. It doesn't translate. So I finally got it working, and this is where we hit the ball. This is just to make the line start at a different time on every spawn. We convert the axis, the angles. So for instance, if you send in 4 as an angle as your angle difference, this is what's gonna do the conversion for us and turn it into an actual rotation that we can use. And this is where this is ran in the update to calculate where the hole is, where you are, and do the angle and location calculations, so we can know where things are and how we're going to get there. And that's pretty much all this class contains. It's not a lot. And here we are in the ball class. It has an aim controller, which we just saw. And here's the putter controller. Take a quick look at that. Putter controller, the angle of my input, and right now I see we can probably make this 180 to 180. That way we get a complete circle difference from where your green line stopped. So we can enter in our angle here and how our power. This is a variable to detect when the ball is moving slow enough that we want to stop it. The physics in Unity, I'm not a physics guru. I'll start my statement with that. But it seems hard to get an object to stop moving if once it starts moving. So I've tried the physics material, high friction, change drag and angular rotation, and ultimately I think I went with your suggestion, Hayden, where you just deal with the angular drag. I think that's what I use the most. But eventually, when the ball still would move a little bit too far, and you'd have to wait way too long for it to stop. So that's the velocity it's gonna stop it at the when it gets to about this velocity. I'm not sure if this is the actual setting because it can be changed in the inspector. So here we detect if we're able to even hit the ball, and we set that other places. So in fixed update, we get an absolute value of the vector that's passed in, so we eliminate all the negatives. And that's an extension. Might as well take a quick look at that. It takes a vector, it absolute values all the properties, and it returns that. And highest value does pretty much the same. It gives you the highest. Well, it doesn't do pretty much the same, but it's an extension method, is what I meant, for vectors. And it just gives you the highest property that's in there, whether it's the x, the y, or the z. Which velocity we're using it in this instance is greater. So here now we say if we can't hit the ball, that means that what we're moving, the velocities we've calculated, is less than our force stop. So that means we've come to what we consider a stop. And if so, if we can hit, we stop the ball from moving. So we zero out the velocity and the angles. Here we calculate the force that we're going to be hitting the ball. So we saw that in the aim controller, but in the aim controller we need an angle and a power. So we just pass in an aim controller and we let the putter take care of calculating, well, sending in the angle and the power. That way these fields are not exposed. They don't need to be. And this is how we hit the ball. We take an aim controller and a rigid body. So if we can hit and our aim is locked, that means you've entered in your angle of difference. Then we calculate the force that we're going to be applying, and that will be done from your power that you've set and the angle. Well, the force is actually only from the power. And the angle is used for, of course, trajectory. And then we add the force to the ball. And then we unlock the aimer so it can do its thing again. I made some changes. I did a quick save there. So those are the two controllers that the ball has. In Awake, we randomize our line. We assign the ball and the hole to the controller, the aim controller, so it can calculate the angle of difference, and we get a reference to our rigid body. To disregard this, just a test method that I was running. Remove the reset ball. We may need to re-implement that as we're doing the Twitch spawn thing, because there's no way to get the ball if it goes off the map. It just goes still. I didn't bother with that yet. So here in update, we check to see if we can hit, and if we can, we calculate the aim rotations. This was for resetting the ball, as it states here. If I press the button, so this is what we need to do on Twitch. We need to enter in these this values that's in our putter, the aim and the power, and we need to hit. So we need to get everything boiled down into something like this. We haven't really covered this yet on the stream, and it's not one of my better topics, but it seems to be one of the better solutions for something like this. And what I'm referring to is the state machine. So defining what state we're in will help us to traverse the tree until we get to actually hitting the ball. Let me explain that a bit more. For instance, there's a series of steps that need to occur before the ball, we can apply forces. First, you need to stop the original aiming. Then you need to do your difference, add in your angle, and then you need to add in your power. You can do the first event. You have to do the first event, stopping the angle first. The other two can come in any order. So, for instance, you might want to change your power first, because if you notice, there's a red line that shows how much power you have on the shot. So you may want to adjust your power first to see if that's enough power to shoot the ball before you actually adjust the angles. So those two can come in any order, but all three needs to be checked off before the hit controller can be fired. And that seems to be perfect for a state machine. From what I've just described, I haven't done anything like that yet, so this will also be something we're going to be experimenting with pretty much. So this is where we want to finally get to. We want to get from here to there. Yeah. Okay, reset ball. I took that again. I blacked that out. We can look at that later. In the fixed update, you call player controller .fixed update, which checks the position of the ball, the velocities, and see if it needs to slow and stop the ball from moving. Draw gizmos. That's where we see the lines being drawn. So once we have a ball controller, and this only really happens at runtime. You see the green line, but you don't see it moving until runtime. You need a delta time to do the calculations, and delta time does not come through the editor. You need a whole new time for the editor. I wonder if it has one. I'm not even sure, but that's what this does. And we have a few more standard stuff in here. This one's not standard. It's actually the camera rig I grabbed out of Boulder controller, and I made absolutely no changes. I just copied the code and pasted it in here, and we have a camera rig. The greens controller, this is like the game controller for each level, or I think Unity calls them level 2, or each scene. So it needs a few references. It needs the ball, hole, T. You assign this in the inspector, the hole number, or which hole this green is managing. The greens, these are the scenes that you'll be loading. So you type into the array in the inspector the scenes that you're going to load in succession. So hole number 0 would be the first index in the array, and so on. The ball, I have it exposed here, but we don't actually assign the ball in the inspector. I just kept it exposed so I can see what's going on. These we do. So in awake, we set the hole number for the T in the hole. We'll check those out. They're very small classes. In on enable, we subscribe to the hole enter event, and in on disable, we remove our subscription. This is what we're gonna do when a hole has been entered. We load next green. We get the current hole number. The hole, again, it has a reference to the number that it represents. So the hole in the scene, it's agnostic. It doesn't really know what hole it is. The greens controller sets up all of that. So now that it knows which hole it's in, and the collider that we're checking for is a ball, we'll check these events pretty soon. Just a note. We load the next green. So we count the hole, we add them up, and we just keep wrapping around. You can stop it at any time, I guess, and load a menu scene or waiting for enough players scene or something like that. And then we load it up. Once we start running, we wait until we get a ball. We keep trying to find it in the scene every frame. Once we find the ball in the scene, this is for the event that maybe the ball's not there right now. Maybe the ball hasn't spawned yet, or any instance like that. It'll hang out here and wait until it finds a reference to a ball. There can only be one ball right now in the scene. So when we do find the ball, we position it at the T, and then we just do a loop here. I haven't done anything here. Well, I have. It's invisible code. So the T and the hole. Let's check those out. So here's our T. It has an event that it fires on T ready. So when the T is when something enters the T, like let's say you place the ball on the T, it says it's ready. So when the game controller finds the ball and positions it at the T, that a collision is going to occur. And other classes can subscribe to that event. So that's pretty much all that happens here. It says when I collide with something, when something enters my collision or trigger box, invoke that the T is ready. I don't even think anything subscribes to this event yet in the project. So onto the hole, and the hole is almost the same. If something enters the hole trigger, fire the event. Action collider int. And where's our hole and T? Action collider int. So in a case like this would be ideal to use a delegate, because the action collider int is ambiguous. It could be anything. It could be used for anything. But in our case here, it's clear that we're actually using it for a specific thing when on trigger enter. So you can actually define a delegate with this signature that when you read the code, you can tell what the delegate represents, instead of a delegate like this that just has parameters and a default name. So this could be a pretty good instance of implementing your own delegate. So that's the T, that's the hole, and I think that's all of them. Aim controller ball, and we saw the extension methods. So we want to subscribe and to this. We need to decide how to create a state machine. Enough